All right, so your quiz, it's just one question about solving inverse matrix, the long one, which is did last time. So that we don't have to do on the exam. Yay. Yeah, so we'll do that exam. And it's a good thing. Now, if you messed up your quiz, it's not as bad as messed up in your exam, right? The quiz is only like 7 points. And you think about it, the total quiz add up is still lower than your homework. Right? So it's like 35 points out of what, 600 points? Your exam is worth much more. So don't worry if you messed up your quiz. The exams are what I'm looking for. I have your exam 3 practice here. Maybe I can knit it soon. All right. I use code to write these. I can't stand the Microsoft. So there will be 9 official questions on the exam with 1 bonus, so 10. I haven't finished the practice sheet yet. Right here, I have 9 problems, but I'm gonna add 1 more problem for the inequality for section 6.1, right, which is we're gonna cover on Friday. So I'm almost there. 1 more question, I can give it to you, right? And your, like I said, your practice exam this time is very, very, very close to your real exams. So make sure you don't mess it up. Today is gonna be very relaxed. All we do is just finish in the last section that we started, which is, it's kind of like review for your quiz, really. All right, last time we talked about inverse matrices, right? Your exam will you have something like this, and you're supposed to memorize that on your own. But for 3 by 3, that's your quiz. You don't have to do that on the exam. Yay! All right, let's start with this one. I want to find the inverse of this matrix. Before I do anything, what should I do? Is there any problem with the original problem? Is there any something weird going on with the original problem? Before you start anything, you're gonna check the original problem first. I don't always give you the best one, do I? Yeah, the 0 in the diagonal, which is usually a bit of light, but we like to have an entry there. So what should I do? With with the row 3, right? So flip it. I'll give you a heads up. If you flip it now, there's a little consequences later, but we'll take care of that later. 1, 2, 3. It's not a big consequences. 5, 6, 0, 0, 1, 4. And now we're gonna write it. We're gonna set it up. You set up. Do you remember how to set it up? There's 2 matrices, right? Left one and then the right one. So 1, 2, 3, and then 5, 6, 0, 0, 1, 4. On the right one, what should I write? The identity matrix, right? The identity matrix, which is 3 by 3. So it's 1, 0, 0, 0, 1, 0, 0, 0, 1. I'll give you a heads up. I'll give you a head start. Why don't you try that? first step, identify your diagonal. So everything below or above it has to be 0. What's the next step? Make the phi 0. Make the phi 0. Anyone have the second row? Then just the second row. Read it for me. Yeah. Okay, looks sounds good. Yeah, sounds good. So what do you do, Bill? So negative 5R, 1 add to R2, right? This give me new R2. Run out of space, I'll write below. So the first row stay the same. I'm gonna rewrite the first row before I forget. So 1, 2, 3, and then on the right side 1, 0, 0. The second row change. So basically you multiply the first one by negative 5. Negative 5 like that. So, and then add to row 2. So 0, negative 5 times 2 is negative 10, plus 6 is negative 4. Negative 5 times 3 is negative 15, plus 0 is negative 15. Negative 5 times 1, negative 5 times 1, times 1 plus 0 is negative 5. And negative 5 times 0 is still 0, plus 1 is 1, and 0. So far, so good. Now, next step, this one 0. But because it's already 0, so you got a freebie. So just rewrite that. So 0, 1, 4, 0, 0, 1. Again, always looking for your diagonal. So what's the next step? Yeah, I kind of make this one 0, do I? I'll let you do that. I'll walk around. We do slowly, step by step. I'll tell you a way to walk around that. Now, don't use, if you can avoid decimal, do that. You can remember, you can multiply the equation by number, right? And it's okay. In order to eliminate 1, what should I multiply row 2 by? It's already opposite, so we have to go outside. 1/4. I don't want that. What if I can do this? I can multiply the third row by 4 and then add to row 2. Is that okay? Is it better?
So you can do that?
Yeah, you can do that. It's the same thing, right? I can multiply this equation by 4, and then I'm going to add equation 2 with equation 3. It's kind of like the elimination method. Just remember which row is changing, that's all. So the first 2 rows stay the same. I'm going to rewrite them. 1, 2, 3. And then 1, 0, 0, 0, -4, -15, -5, 1, 0. Like I said, I do not like fraction. I like, if I can find a way to work around it, I would. I multiply the third row by 4. So quadruple the third row. And then I combine the two together. Then I got new row 3. Just kind of like elimination method, right? It is elimination method. So 0, 0. Four times 4 is 16 plus -15 is 1. 4 times 0 is 4 plus -5 is -5.
No.
Oh, where am I? 4 times 0 is 0. I'm right here, right? Yeah, 4 times 0 is 0 plus -5 is -5. 4 times 0, 0 plus 1 is 1. 4 times 1 is 4 plus 0 is 4. Do you have any question on this step? Yeah, somebody else can multiply 1/4 to row 2, add to row 3. It's the same thing. You just have to deal with fraction, right? And we don't like fraction. It's just easy to make mistake. I kind of keep eyeballing for my diagonal. What's next? Huh? Yeah. So that's the lower triangle. I gotta get the upper triangle 0. Which one first? This first? This first? Yeah, -15 first, right? So -15 be next. So that's gonna be 0. What row should I use? What row should I use? The third one, right? You don't want to use row 1 because if you use row 1, you're gonna change. So use row 3. What should I multiply row 3 by? Yeah, 15, thank you. Sorry, I didn't hear that. 15 R1, I'm sorry, R3, add to R2, give me new R2. The first one stayed the same, 1, 2, 3, 1, 0, 0. The third one also stayed the same, 0, 0, 1, -5, 1, 4. Second one is the one that changed. For the first one, it does not change, right? Anything comes 0, 0 is 0, add to that, stay at that. So 0, -4 stays the same. 15 times 1 is 15 plus -15 is 0. 15 times -5 is -25. Add to -5 is -8. 15 times 1 is, where am I? I lost track. 15 times 1 is 15 plus 1 is 16. And 15 times 4 is 60 plus 0 is still 60. What's next? Yeah, the 3, 0. Just gonna keep track of the thing, right? Which row should I use? Yeah, well, you can't either row 2 or row 3, right? You can't use row 2 because it's 0 here, right? It's no help. So row 3. So what should I multiply row 3 by? Yeah, -3 R3 plus 1. Give me new R1. So the last two rows stay the same. I'm going to rewrite that 0, -4, 0, -80, 16, 60, 0, 0, 1, -5, 1, 4. All right. The first two stay the same, right? Because the 0 does not change anything. The last -3, 1 is -3, add to 3 is 0. -3 times -5 is +15. Add to 1 is 16. Am I doing anything wrong here? I feel nervous. I don't know why. Did I do something wrong? I'm like, I feel nervous. I don't know why.
These are so long.
I know, -3 times 1, -3 plus 0 is -3. And then -3 times 4 is -12 plus 0 is -12. This one make me nervous. That's the only one that make me nervous. I don't know why. All right. Next. Your last and the last one, 2. The 2. What should I do? Well, I can't use row 3 anymore, right? Because at 0 there is no help.
Wait, so now, can you multiply first row by 2 now?
Yeah, that's what I'm gonna do, right? Instead of doing fraction, right? So we're gonna double the first one and add to the second one. Right? Maybe I'll do slowly on this part. So is it double the first one? Give me a new first one. So 2, 4, 0. Make sure you double the right side as well. 30, 32. -6. -24.
Can you skip a step?
Yes. Huh? Yeah, you can skip. I'm just doing slowly. Yeah. 0, -4, 0, -80, 16, 60, 0, 0, 1, -5, 1, 4. And now I can add row 1 and row 2 together, right? I just kind of do slow. You can do it just one step, just like we did here with the multiply row 3 by 4. I kind of skipped a step here. I just kind of expand it out because I have space. Now R1 add R2, give me use R1. Remember, that's the one we want to eliminate. Like usual, I write too large. So 2, 0 plus 2 is 2. -4 plus 4 is 0. 0 plus 0 is 0. It should be. -80 plus 32 is, what is that? 48, right? -48. 16 plus -6 is 10. And then 60, -24. 36. Yeah, thank you. All right, and the last two rows the same. 0, -4, 0, -80, 16, 60, 0, 0, 1, -5, 1, 4. Almost done. What's the last step? Everything is 0. Yay. Above and below. All we have to do is what? Remember, this has to be added matrix. So I need to make the 2 and the -4 to be 1. So what should I do? It's the easiest step. You guys, step. Multiply the first one by a half, right? By half, right? By half. So 1/2 are 1, and multiply the second one by -1/4, right? And we're done. Yay! Almost. So if I divide everything by 2 on the first one, be 1, 0, 0. -48 divided by 2 is -24. 10 divided by 2 is 5. 36 divided by 2 is 18. 0, 1, 0. Negative 80 divided by negative 4 is positive 20. 16 divided by negative 4 is negative 4. 60 divided by negative 4 is negative 15. Yes, negative 15. And then rewrite the third one. Yay. Oof. All that work. See, that's why I don't ever put that on the exam. It's just not practical. But I gotta make you do it somehow, just in case you had on the final. All right, now I'm gonna show you how to do it in your calculator so you can check your work. But like I said in the beginning, there's a little consequences because what we did in the beginning, we swapped the row, right? We swapped row 2 with row 3. So because inverse, everything switch. Domains become range becomes domain. You swap rows at the end, column swap. So let me show you what I meant by that. I'm gonna go old school and use this. No ass. All right. Come on. The second matrix. Go over edit. Matrix A is a 3 by 3. Plug in the original. 1, 2, 3, 0, 1, 4, 5, 6, 0. Enter. Make sure you put enter at the last entry. Second mode to quit. Go out. Names is A. And you don't want A, you want A inverse. So you see that little X at the -1 there? Press that. Almost. What happened? Compared to the result what we had, what happened? The second column, the third column, they switch, right? Because we switched the second and third row, right? So it's nothing wrong, it's right. Now if I modify my matrix, I enter in 5, 6, 0, and then 0, 1, 4, the one that we modified. Now we got the right one. Right, it's the same thing. On the quiz, I'll make sure that you don't have swap row, okay? So you don't freak out when you have different answer. Yes?
How do you determine what your inverse is?
Huh?
How do you determine what your inverse is? Like in the beginning?
You can't. But you have to either check with your calculator or you work it through.
No, like when you write like the other side in the beginning.
Oh, you mean?
Like 1, 0, 0, like how do we know how to set that?
Oh, so the setup is this. This always your, it's so big. This always your A. It's okay. It's always your A, and this is always your always your identity. That's how you set up.
And how do you determine your identity? Like the other
3 by 3. So identity is always, the diagonal is always 1, right? And lower triangle, upper triangle is 0. So if it's 2 by 2, then what?
in the last example, you had the 3 by 3, the identity
More. I fixed it.
Oh.
I fixed it. Yeah, I had a mistake. I made a mistake.
Oh.
I think I think somebody asked it last time too. Was it you? Yeah. Yeah, it was my fault. I'm sorry. I put an extra 1 there and I fixed it. Yeah. So we good?
Okay.
Sorry about that. Like Mimi, you make it harder than it should be. I didn't mean to. All right, here's the deal. So this will be your quiz on the exam. Nothing like this. We're gonna use calculator on the exam. So so far, so this is an equation. So far, how many methods we solve in system of equations? Two, right? By elimination, or by Gauss-Jordan elimination. Now, today we're gonna learn a new method. It's called solving the equation with the inverse. So if do you guys remember ax equal b? Remember that from last time? If you don't, maybe I'll go back. Is that this one? Yes. So on the exam, this is something will be on your exam, something like this. On the practice, I make it into a story problem. You also have the extra step for the practice exam that you have to come up with this, which is harder than the exam. But you rather like that than the other way around, right? So if I give you a system equation and I ask you to solve this system equation using the inverse, then this is what you do. You rewrite it as a form ax times bx, a times x equals b. What is a? A is your coefficient matrix, just coefficient of x, y, z. Your capital X is the column variable. In this case, we have three variables, so x, y, z. The two variable is just what? X, y, right? And then B will be your constant column. So on the right side of the equal side. All right, so let's set this up. If I want to solve for x, what should I do? Huh? Huh? Careful. We cannot divide a matrix. But what do we have? What do we have to cancel the A? The A inverse, right? Yeah, we can't do that, but we have the A inverse. So we can multiply both side by, yeah, A inverse. Now, like I said, matrix multiplication is not commutative. If you put A inverse to the left on this side, you have to do the same thing on the other side. And I'll show you why. But for now, let's just move on with this. A and A inverse cancel out, give me what? No, just A inverse. I'm not. A inverse times A is one in matrix. Call that the identity matrix is I. Oops. On the right hand side, just A inverse times B. No simplification there. What's I times X equal? What's 1 times 2? 2. So I times X is still X, right? So remember, X, I is kind of like number 1. It's kind of like number 1 in real number, right? Right there. So that's how you solve for it. And we're gonna use calculator for this part. So why don't you write this in matrix form for me? A times X equal B. What is A? Yeah. Oh, by the way, that's Z. Oh, my bad. I'm so sorry. That should be Z. That should be Z. Typo. So 2, 1, 1, right? And then 3, 2, 1. 2, 1, 2. What is my X? Yeah, X, Y, Z. If it's 2 variable, it's just X, Y. If it's 4 variable, then X, Y, Z and something else. My B will be 1, 2, negative 1. I want to solve for X, Y, Z using the inverse. So I'm going to multiply both side by A inverse, right? So I'm going to multiply the left side. Two, one, one, 3, 2, 1, 2, 1, 2. That's not inverse, but if you do like that, you put a little negative 1 on top, that's indicate it's inverse, right? And you do the same thing to the right side. Make sure you put on the left of this with the column B. 2, 1, 1, 3, 2, 1, 2, 1, 2. So far, so good. Multiply both sides by A inverse. On the left hand side, A inverse and A cancel, right? So you just, oh, good. Come on. X, Y, Z. On the right hand side, we're going to use calculator. All right. In the calculator, go to matrix, over edit, 3 by 3, and pressing a matrix A. Matrix A is 2, 1, 1, 3, 2, 1, 2, 1, 2. And then second mode to quit, go back to matrix again. Oops, sorry. Go back to matrix again. Go over edit, go down to matrix B. It's a 3 by 1, right? It's a 3 by 1. 1, 2, negative 1, I have it right there. Second mode to quit again. Go back to matrix, names, matrix A. But I don't want matrix A, I want A inverse. So press this button. And then second matrix again, you go down to B. There's your solution. This is the best method and the worst method. It's the best if I let you use calculator. It's the worst if I don't. Right? So is on the exam, huh? Not A inverse, no. This is your calculator. I don't want to grade that either. It's painful. Especially people who don't not need about their work. Like, oh God. So that's your solution. Yeah, -2. Okay, so here's the deal. On the exam, you have something like this. This is the minimal work you show me, okay? Don't just go from here and here. I don't like that. At least show me something. At least I know that you take care of the part that you multiply the matrix with the right order. Now, say if I being careless, I multiply A inverse in this side, but then I put the A inverse on the right side of the B matrix. What happens? Can I multiply? Can I multiply them together? This is 3 by 3. This is 3 by 1. You will be able to multiply because what? The inner dimensions match, right? Now, if you put that black matrix to the right of the red one, what happened? Say this is your B 3 by 1, and then 3 by 3. No, it matters. You cannot multiply them. They're not the same. Yeah, it doesn't match. Yeah, that's right. That's it. That's why matrix multiplication, they're not commutative. They're very picky about where they are, right? So be careful with that. Any question about 5.6? 6.1 is very easy. Something you learn in 661 if you took the class. Let me ask you a question. If I graph an equation, if I graph an equation, then the solution of that equation if I graph a linear equation, say this one becomes 2x minus 3y equals 6. What do you see? What kind of graph you see? Is it a linear equation? Huh? A linear equation, so what kind of graph it is? Huh? Yeah, it's just a line, right? And all the points on the line is a solution of that equation, right? Now, instead of equation, if I have inequality, I say I have greater than. What do you think is gonna happen? There's a boundary, and then what? Is the solution on the line anymore, or what? What kind of the solution? So here is the solution is on the line, but here the solution is a region, right? It's a region. It's no longer a line. It's a region. So maybe check it out. Let's check it out on decimals. Decimals, great. Two x minus 3y greater than 6. So the shaded region will be your solution, right? It's no longer a line. As a matter of fact, in this case, the line is not a solution because I don't include what? I don't include the 6, right? I don't include, so that's why it's dashed line. I mean, every point on the dashed line is not the solution of this inequality. Right? So whenever you have strictly greater than or strictly less than, you can have dashed line. If you have greater or equal to, then you have a solid line, right? Or less than equal to.